Railway Conversations with Doc Frank.
Today's episode of this podcast is a special on the topic of testing. It dawned me that a number of episodes in the past have been about the topic of testing and commissioning of railway signaling projects, and I present to you today highlights of interviews with different speakers from different episodes. Episode 13 with Artur Wolnica from Poland. Episode 21, Danny O'Connell from Brisbane in Australia, originally from the UK. Episode 23 with Frenchman Frederic Sancho, currently living and working in the UK. And episode number 34 with Xavier Ricco from Belgium. Please enjoy this collection of great insights from the testing world of railway signaling. Hi, it's Doc Frank here. Real quick, I want to let you know about one of the best CBTC trainings in the world, if not the very best, but you always need to be careful with superlatives. It's the CBTC Kickstarter online course. It consists of 30 video lessons, that's the 3 with the 0, in total over 11 hours of training content, talking about everything from the basics of CBTC, current standards, the benefits of CBTC, the key functionality of it, the supply industry, application tips and tricks, lessons learned, do's and don'ts, case studies, arguably the most comprehensive training that you can find anywhere on the topic of CBTC. There are a few additional things that make learning easier for you that you may not find on any other online courses. One of them being an immersion plan that helps guiding you through the training course and progress it in a finite period of time instead of just having it sit there for months and months on end. There is access to an online study group where you can connect with other students who are doing that training course at the time and form learning groups. And after the training, you will not be on your own. There is an alumni community that allows you to ask questions about the course content on an ongoing basis. So it's basically education for life. You can register on my training portal, which is docfranktraining.podia.com/CBTC Kickstarter online 2023. I repeat that, docfranktraining.podia.com/CBTC Kickstarter online 2023.
In this clip from episode 13, Artur Wolnica talks about the importance of mentors when you start new in the railway industry.
What is also important, I think, that I was able to find there were also right people who introduced me into this railway engineering career. And it's probably most important factor, because if the people were not there, may have been discouraged, for example, and it may have ended up very quickly. But because I met very good people who were very supportive, who gave me a lot of feedback, a lot of trainings, who spent a lot of time for me, I was very happy that they played a very big role in my development. And if not for those people, then I would say that I wouldn't be where I am right now, because simply I would probably switch if that would not be in my interest. So I think these are the certain points that happened. And of course, there was this little bit of a luck as well, that there was some opportunity. But what's important is, even when you don't have this railway background, you still can learn a lot. And this is not mandatory constraint or condition that qualifies you to be a railway engineer in the future. So I think you should, or people should not be discouraged if they want to grow in the railway engineering, that they don't have enough experience, because experience is not something required when you just start. Over time, you build up the experience that you will use in the project, or you will see whether this path is something for you. But initially, it's not something that is mandatory to join this area. My injection into the ATCS, where I just started, like even from day one, I could have play around with the system. I had it. And even without the proper knowledge and the background, it didn't play a big role there, because it was my own interest that, okay, I have some engineering, devices here or some hardware, software, where I have to check how something works and I have to investigate a lot of things. And I think this jump into a little bit big water was very interesting on one hand side, but also very good because that's even without this prior experience, you can just feel it. What is it all about? You can just get a glimpse of this whole system. Of course, you get a more exposure after you see it in the operation, for example, in the vehicle. But first initial one, when you have a test center or the test lab where you can just do whatever you want, it's like a safe environment. And you have a lot of colleagues around you who are senior, who give their time for you, who give you the materials. And this is like an investment in like beneficial for both sides, because you benefit as a person who has just joined, and the other person also benefits, or the company benefits, because the company is growing up, the new talents or the new people, the new resources that may stay for a longer period of time. And of course, it's also about the person, him or herself, because you either have this willingness to learn, or you just want to stay aside and just don't want to do much. So it's always this personal interest also. And in my case, I was always interested in taking up the new challenges. So that means that whenever there was any opportunity to check something or to jump into a new topic, I was always ready, I would say, just to be thrown away and then thrown into the big water and then see if I will handle that. Because of this, I think, attitude, it also plays quite a big role here, especially ETCS is a safety system. So you have to have a lot of, you need to be always maybe, you have to always have this willing to learn, because there's a lot of information that you have to proceed. And initially you don't have this information. After a while, you just reread some documents or just the principles, the specifications. And for me, myself, actually, it happened even 5, 6, 7 years after I started, that I just took on a business trip a lot of papers, specifications that I started with initially, and I did a lot of like highlights or some notes, and it was like a solidifying of my knowledge that I collected initially. And then I was maybe thinking over some topics that were not understandable in the beginning for me, and then over time, in the next few years, when I went back to these topics or these principles for the ETCS, it was more clear for me. And sometimes even I discovered new things and which I was not aware before. And also that's important because all the systems are evolving. ETCS is evolving. We have a lot of different baselines, a lot of different versions of the system, where if you just stick to one version, which was initially there 10 years ago, then after a while you will be not up to date. And then you may face up some situations when you are doing something and then you expect something else that should happen, that normally should happen because of the new version of the specification, for example. So this constant learning is also some important factor that over time you or someone should develop in order to be always upfront to the new challenges that are coming.
In the next clip, Artur talks about different ways how ETCS, the European Train Control System, can be tested.
There are several ways how it can be achieved. So, of course, the field test is ultimately the part that cannot be, in my opinion, skipped in the authorization process or in verification, validation. But there is also another way how it can be done without being in the field. And here comes the interoperability in place, because we have there is a couple of test centers in Europe where you can just take our system, either onboard or wayside or interlocking, GSMR, RBC, whatever. Then you keep it in the lab, and then you have the real, like the same infrastructure is in the lab that in the field. And because of that, you can do a lot of tests in this closed environment, safe environment, without disturbing the railway operation somewhere in the field. And there is a lot of positive aspects of this because first one, of course, you can save a lot of time by the preparation. Secondly, you can do more in less time because you don't need the vehicle. You just have your system. You just confront it against some other supplier systems. And that is one point which is, I think also the awareness is growing in Europe that such test centers is really needed in order to implement the system quite faster or do a lot of things in a faster way than just rather doing everything in the field. I could relate to also one important point that you mentioned, that you cannot really simply switch off the line from the operation. There is a passenger services running, and of course, there are certain lines where you can access during the day with a vehicle, but you may always be exposed to some problems, because if you cause a problem on the real operation line, then you cause a real delay to the passenger trains. And in fact, this also happened in the past in some of the tests where I attended, that because we did some test runs, and of course with a system that was not yet authorized, we may have expected some issues or failures, and therefore some risk is always there that the passenger service will be affected. So also, as you mentioned, one of the possibilities that is used already during the field test is that the lines are used during the night, mostly for the tests, but that also brings a limitation, because if you have a lot of suppliers that want to test their systems, and you got only this short period of time where you can do the test, that makes it that there is a real queue for the access to this railway networks. And you have to plan in advance, sometimes within the weeks or even months, some test runs in the field if you want to really get your system authorized. And then if you just, if you miss the slot or if something happens, then you need to plan again. And this makes it very complicated. In Switzerland or in the Netherlands, you can only test during the weekends and during the night. So that's also many more constraints is there, because you cannot simply go whenever you want. And that's why it's very difficult. And also during the night, you only limited amount of time. So usually that's when the last passenger train leaves the track. And so, for example, from 1 o'clock until 5 o'clock, you get a time period when you can do the tests, but it's only about maybe 4 or 5 hours, nothing more. And as soon as you get to the 5 o'clock, you have to leave the track. Otherwise, you will cause the delay of the first train, which may interfere with the next train. So that's a very, very, very complicated. Even in terms of the planning of test plans, you have to plan a certain amount of tests for the night. If you get only limited time of the test, like 5 hours, you have to plan your test in a very detailed way. There is no space for having any, sometimes you can plan some retests, but normally if you test according to the schedule, you cannot go outside of the schedule, because you may be overtime or you may cause some delays. So that is a lot of things that is playing a lot of big role here. But I think that what can be done, and as also mentioned before, as that part of the test can be done, I hope in the future the field test will be replaced partly by the equivalent test that can be done in the lab with the same infrastructure. The infrastructure must be the same as the one on the track where you are going to have your authorization. That is very important. So the supplier of the track side has to ensure that it's in line with the one that is run on the track.
In this clip, Artur talks about ETCS interoperability, experienced issues with it, and how testing is needed to get it right.
I did some interoperability tests in some test centers in Europe when on this level, without going to the field, we found out that there were a mismatch in interpretation of some requirements. Even though they were standard ones that had to be obeyed by everyone, every supplier, there were still some cases where it was not really clear about some certain technical aspects. So one supplier understood it in one way, the other supplier understood it in another way. So in the end, they did not match. But because we were on the lab level, or we didn't go into the operation yet, that also saved a lot of time in the end, because it was discovered relatively on the let's say in the middle of the project, so there was no problem in let's say modification of part of the system. But if this would have happened later during the operation or during the field test, then we would need to go back to the stage of the development. And of course, this would take a lot of effort, costs, time for just making it up and running again. Yeah. That's why it's very important. Yeah. Here is only the aspect about the interoperability within one country, but we also have this broader aspect of the interoperability as a whole between all the countries. And here is also, at least, I've got a really good example for this case, because we did a lot of test runs in the past between the Netherlands and Belgium. We had a project that for the passenger line from Amsterdam to Brussels, it was back in 2017. And I remember it very well, because it was like every weekend I was in Amsterdam where we started, and we did a lot of test runs over the border. And it's been a very extensive test campaign for several weeks or even months. And the interoperability there was very difficult, because you had to fulfill the requirements coming from the Netherlands on the one hand side. Yeah. You had the Netherlands, and the other one had Belgium, which had different set requirements. So you actually needed to fulfill everything from the Dutch side and everything from the Netherlands side. But there were also differences in the implementation of some certain aspects. For example, the GSMR network had slightly different requirements on one side of the country than on the other one. And that meant that also within the ETCS system that were used on the vehicle, it also had to obey two conditions, I would say, one from this country and the other one from the other country, which was very difficult to achieve, considering that the border of the countries were, let's say, also in the GSMR network, were like an overlay. There was like in Hanover, and a lot of information was exchanged within the system itself. Therefore, these differences make it very difficult to find the right solution in the end. And we spent a lot of time there just to find out what is the best configuration that can be used there. So on this European level or on the country level, interoperability plays very important role, because that's the basic principle of the ETCS. We want to start in Portugal, we want to go to Norway, for example. And this can be achieved, of course, but there is interoperability plays the crucial role here. Without this, it will never be possible.
Danny O'Connell talks about the often overlooked complexity of testing and the high importance of integration tests.
There's two parts that fall out of this, yeah. Ride quality is one part of it, but then also the noise and vibration impacts as well. Again, looking at tunnel environments, let's say even where we've got external neighbours that are quite close, these are big impacts. I've seen it on tramways where let's say a floating slab track has been installed, but people have not appreciated the noise and vibration and the proximity to, let's say, people that live adjacent to the railways. Yeah, these are big impacts to people's lives. This noise, so it's again, going back to the point, and that's the reason we test. Yeah, people have let's say, people that are not from a systems background or, let's say, a TNC background, sometimes don't appreciate the volume and depths that we go to. And I just want to go back to the previous point. Platform screen doors, we do or die by these, yeah. So that door inhibition test you mentioned, yeah. So the scenario in my head is that, again, a train pulls into a platform, let's say Canary Wharf as an example from the Jubilee line, yeah? We've got lots of passengers waiting for that train. If there was no signage, yeah, on that train, yeah, as it pulls in, the doors don't open, you have passenger overflow issues at that point. Yeah, so that baseline test for me is that a train door has failed. Yeah, the communication path between, right, you said, from the onboard to the settling to the PSD. Yeah, train pulls in. There's a visualization. There's a big X on top of the door explaining to people not to board at that location. Yeah, and likewise on the train, a relevant alarm is generated to the back of house as well to identify we have an issue here. Yeah, and again, people don't understand that these are probably the most integrated tests that we get, that we have a failure on board or a failure on the wayside. And what does that mean? So it's information being presented directly. And that's a really, really good part. And then the second or the first part of that point, door synchronization. Yeah. From a pure PTI security process, yeah, door synchronization needs to work. We need to make sure people are not entrapped behind that PSD door as well, yeah. And it's making people understand. There's people, again, with PSDs, people have an opinion that, okay, we can do 1,000 cycles in the factory. Yeah, we can do 1 million cycles. Trains to actually deliver the PSDs to the platforms, do these cycles. The part that's the fundamental element of that is the integration, yeah, working in unison, and that big part there. And that always comes back to me of going back to some of the TNC philosophies of like, how do we de-risk, let's say, a PSD interface, yeah? We can test it, as I said, in a factory. We can test it in a lab, yeah? However, the real interface is when you put the three systems next to each other. So that could be the train, yeah, PSD and signaling. Best locations for that predominantly are in test tracks, yeah? You can de-risk that activity and these issues and fine-tune it before it comes to the tunnel. And that's where I believe sometimes people don't appreciate how you can maximise off-site testing and what de-risking of an activity actually means as well.
In this following clip, Danny talks about time pressure on testing activities and the feasibility of 100% test.
So if you look at it from a purely PSD part, yeah, as I mentioned earlier, that off-site testing, let's say you've got a trains in a depot, be there any country in the world for a new project. If you install, let's say, an element of a signaling system, an element of a physical platform screen door there, you could pass every train through that as it comes out. So they're type testing every time. The main part for me of actually testing in the tunnels, again, it's the SOAP testing. So you would have as per your technical requirements, and it's, say, across your VCRM, so basically your link of a requirement to an opportunity or action, be that a test. You can perform these tests. I really believe it's the SOAP testing part that is the benefit. So what I mean by that, if you have 16 hours a day for testing, as an example, in a tunnel environment, the 8 hours, what you would utilise that for is run a train up and down. So not under a test, but just a SOAP test. It will pull up into every platform. It will open a door. Yeah, and you test and you test and you test again. That's my way of trying to maximise the time of both off-site, of putting these trains all through the same environment, and then ultimately whatever trains you need to get into that tunnel. But again, volumes of trains are always going to be, I don't believe you can do 100% of the testing on 100% of the rolling stock. Yeah, you can validate elements of it. You can do some type testing. You can do some regression testing, unless you have all the time in the world. But predominantly, it comes down to program pressure, as you rightly mentioned. So I believe it's the variables and how we can de-risk it. Again, my mind, depot or yard being one, and then let's say maximising the hours that you've got during a testing period. And to be quite honest with you as well, Dr. Frank, yeah, we're always going to be reduced for time. In a test environment, yeah, I'm looking predominantly at the railway corridor here, yeah. We're always going to be reduced for time that we have, because potentially when we start running trains, the build isn't finished, yeah. So the way that we try to mitigate this in my mind would be Monday to Friday, we have 16 hours of, let's say, train testing, real train testing. We may get 10 or 11 hours of actual wheels rolling, so test time. However, the second 8 hours in my mind could be that function. Running a train up and down. Friday evening, we put the trains to bed. We hand back to the construction and the maintenance works to be done. Likewise, on a Monday, they hand back to us. And in parallel to that, the way that I would literally to deliver a project, every 6 weeks, we have a week shutdown of testing. What does that give us? That gives us time to deploy any new software. Yeah, if we found errors on lods, but it also gives the construction and maintenance team time to go back and resolve any works, but also give the test teams a little bit of respite as well. So that's the way that I would look at that whole delivery cycle from end to end. But again, with unlimited, let's say, restrictions on time and people wanting access as well, because the big part that I always find in say, delivering metro systems with new tunnels and new stations is you've got two very different work streams that are intertwined, but both want priority across each other. So that's the railway corridor, then the station system delivery. And the impact of that station system delivery on the railway corridor upstream could be someone's isolating a distribution board that has downstream impacts that we don't have voiced from, impacts the signalling system. So it's always quite difficult to play them off, but they're both fundamental delivery milestones for a project that need to be controlled and work in parallel. If they don't work in parallel, then you're going to find it very, very hard to succeed.
In this third clip, Danny addresses the question how tests can be compressed if there is not enough time available for full-scale testing.
What are the requirements to test? Yeah, so we have a requirement. What feeds off that is obviously the test that we need to do. So that includes the interface systems, the durations. Yeah, once we have that, what I would call, let's say, the test database. Let's say we have 1,000 activities that we need to perform. We know that these are safety critical interfaces, priority calls. Then we try to look at what can be tested off-site. Again, I go back to the point that I made earlier. So what can be validated? Yeah. Off-site, be that in a lab, be that in a test track. So we try to de-risk that part of it. But then we need to look at what predominantly happens on these projects when time is squeezed is that we say, right, we have 1,000 activities to perform. Yeah, we know that the software drops will give us these various functionalities at different points in time across the project. And then we have the actual build. So it could be that the railway corridor is being built, going ahead, proceeding as it should be. However, the tunnel ventilation control system, yeah, the functionality of that, so that the remote control of that, yeah, is not available. So we don't have the software interface. So we can facilitate tunnel vent by local control, which is fine, but that then proves that our testing is back-ended. So once you overlay the software availability and functionality to the systems required to the actual infrastructure availability, you can prioritize your testing on location-based activities, yeah. So that's one level, but I think it's the scrutiny of the planning. The scrutiny of the planning for me is if you're working to a T-6 process, what I mean by that is a T-6 weeks, you're scheduling your tests day by day. Yeah, you maximize the time you have in the tunnels. Yeah, we know, as per the test database, that these 30 scenarios are critical one items that need to be performed. So that's my part of it. Let's say T-52 weeks out, strategic level planning. We need to know of the 1,000 scenarios that we need to do, what are safety critical? What are our priority? And that makes your planning and coordination a lot easier rather than running at that last minute. Yeah. So I think it's the elements of control that you put around planning, what you put around implementation, and then what you put around literally analysis. What I mean by that, test, pass or fail. Yeah. If we have a fail, what does that look like? Is that a safety critical event, or is that failure relevant to someone not knowing how to perform the test, or is it a functionality issue as well? So I think the building blocks that you put around TNC facilitate that or allow you to prioritize the test that you need to do, but also manage people's expectations. You've clearly identified that these, say, 30 scenarios are critical for the delivery. The amount of time you're able to do that, you've done these. And the back end of that is that subsequently you have these 970 tests that need to be performed elsewhere as well. So
Frederic Sancho talks about how to attract specialist resources for the complex testing task in large projects.
Obviously, resources are scarce, but they do exist. Now, what most people tend to forget is that if you pay peanuts, you get monkeys. Okay? So in our line of field, we pay good money, which means we don't make that much money ourselves as a company. But we are organizing ourselves so that the overheads are limited. Okay? We don't have a fancy business office in the city of London. We don't. Our office is in Whitney, a very nice village outside Oxford, where the prices are really different than London, for instance. And that's one example among many where we effectively do things in a certain way, and our margin. Obviously, people believe we are kind of very wealthy people. But in reality, we're doing well, but we're doing well because we treat people well. And those resources, which are specialist resources, I can tell you, they wouldn't argue with me on the podcast. They are paid a very good price, and that's why we can get them. That's why we can, and we not only we pay them well, we also treat them like human beings, which it seems obvious, but it's not that obvious, and that's important. I think beyond the wages, the guys are also responding to the way you treat them, the way you care, the way you effectively ask about, is everything at home all right? Sometimes you can see some change in behavior. Immediately we don't let that rot somewhere for months or weeks. We get involved, and yes, it takes time. It takes I would say energy, but that's the only way I can do it, or we can do it now. I'm not the only one.
In this next clip, Frederic talks about ways to acquire knowledge and eventually a specialist status, and also about a sensible mix of specialists and less experienced staff.
I was kind of green to this. I had not done it before. I was lucky enough to be put in the position to learn, surrounded by a client who was extremely technically sound. So I learned from them more than I learned from my own company. Okay, I learned from the client. I learned from Bechtel. I learned from Sistra in particular. So I absorbed everything they were happy to share, and they were happy to share. So I was very fortunate in that respect. But I also learned that you can also give opportunities to people that do not meet the specialist criteria always. Okay. However, as you said yourself, a core team of people who know what they're talking about is essential. But that core team doesn't have to be expensive in terms of expanding. It doesn't have to be big. It has to be right. And then you have to populate the rest of the seats around the table with people like I was one day, which was a bit green, but willing, with a lot of appetite to learn. You have to make good choices if you're going to recruit people who are kind of young and inexperienced, and that's very often a gut feeling you get or you don't get. Now, my own experience, and it's silly because it's a kind of a Murphy law that is repeating itself. People do not want to spend the money until they have no choice. What I mean by that is that very often you have months of procrastinations, months of even a year or so of procrastination. Oh, we're not going to spend that kind of money. There's no way we're going to get that specialist in, blah, blah, blah. And I can understand where they're coming from, because I'm an entrepreneur myself, and I want to be sure when I do the same thing that my choice or my decision is really value for money, because it's expensive. Okay. But the reality is they wait until it's impossible to do otherwise, and then suddenly the price has doubled. Okay, so they didn't really make any good investments. They made an expensive investment, because at the end of the spectrum, people tend to be rarer than they were before. And the one you can't find, they say, well, I was happy to come for, I don't know, £500 a day. Now I'm happy to come for £750 a day. And then you have no choice. So planning and budget planning is one of those. Sometimes you want to save the pennies without realizing it's going to cost you a fortune in the long run. In particular with testing and commissioning, which is my core, not the core business, because we're doing so many other things, but it's how I've been involved myself on the tools, if you prefer. And this is a complex thing. I mean, you had Danny O'Connell on the podcast, so you know exactly what I'm talking about. This is not a simple job. Managing this takes a lot of insights, and you have to be really knowledgeable. But the reality is, you don't get that kind of knowledge and specialism for free or for little money. But if you engage with those people and effectively you pay expensive rates, or you pay market rates, shall I say, instead, then you get better results. So instead of spending years debugging something or wasting time sending people to correct stuff, you've done it right first time, or at least close to first time. And the difference between the two is people in the know versus people with little knowledge, etc. So don't get me wrong. I'm not saying automatically if someone is expensive, they are better at the job. It's not true. But there is a fine balance to find.
Xavier Ricco talked about the development of first testing tools for ETCS and the significant improvements in testing times achieved with those tools.
I was involved in the working group in the very beginning to design and update the baseline 2 test from 222 to 230, then from 230 to 230D. And that was my preliminary experience. From that point, we started to dig into development of validation tools. That was our deep first experience. And with, let's say, third-party product, and we studied that product, we understood that how it works. But the problem we had that was we had to be, ISO 17025 lab. It was one of a piece of challenge we had to face in our history. And in order to have control and independency, which is the key element there, we needed to develop our own tools. So we started to complement what we had, which was missing there, with validation tools. We incorporated a camera to acquire the display that we were visualizing on the ETCS part to qualify whenever the display was doing the right job or not in a black box testing principle. And then we extended this tool to finally the essence of the test bench, the heart, the capability to gather data from the device under test on the one hand, to register every information getting from out of the device under test in isolated mode, and then to validate based on the data, on the tools we already developed upfront, to validate the behavior of the tool. So our deepest experience in this area remains on the validation. And these years of experience we had brought a series of, let's say, innovation, because we come from different departments in multi-tail where you have electronic, you have computer science, you have signal processing, and so on. And this merge of competencies, multidisciplinarities, brought where our tools where they are today. We spread around different areas in the world, and thanks to the innovation we had, thanks to the automation we brought to our tools, we could reduce a test campaign, traditional test campaign, baseline 2 test campaign. So just to start with the kickoff, which was lasting 9 months to manually verify steps, the DMI, display, blah, 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 down to 1 month. Thanks to the automation we brought, thanks to the fact that we brought repeatable, reproducible, without human factor as much as we can in the loop. And that was the first, let's say, the first score we made there, I would say. We really beat the challenge of optimizing the process, reducing time, and bring in the end what the client wants. He wants its test report as fast as possible, because otherwise it will slow down the whole process, in fact.
In the next clip, Xavier talks about the benefits of automation for testing.
The automation, the use of robot in the end was, in the end, it works 24 hours per day, 24/7, voilà. And in the end, we also reduced the human factor in the process. So that's definitely what we are always challenging in our context. There is always a risk there, and one interesting topic I always share when I try to expose what we do is we put, instead of using one single camera to monitor the display, we have two cameras. The reason behind is the fact that we started first with one camera, and when we put our hand in front of the icon that change, we need to repeat the test again because we have hidden the evidence that we have to validate. That's one thing. So we put two cameras and we develop strategy to recognize the display, to perform, to see through the arm of the robot itself. But it started with the hand of our operators, in fact. And this is more than 10, 20, 12 years of development in the background that we improve regularly, in fact. And in the end, we started first to it's public, so I can share that. We started first with certifying famous Japanese company called Hitachi. It's public, that's why I share this. And they acknowledge, they recognize the fact that we really beat the score on the performance. We could reduce their test campaign down to 1 month only. And in that context, they wanted much more than only going to the lab. They wanted some tools, in fact. So that was the kickoff for us to determine the fact that, in the end, the validation tool we brought are valuable for our customers. And then we need to somehow start to sell it. And that was another story, in fact. The aim of this was to prepare, in the end, the end customer, to be ready for the exam. So it's like a pre-test phase, and they have as many time they want to exercise their system. And because of the fact that we optimized it, it was really bringing added value for them.
The last clip is specifically related to ETCS applications in different states along the Australian East Coast, and Xavier outlines how testing tools could help with facilitating interoperability between those states.
There is a deep link on our last big contract we won in the UK, in fact, for Network Rail. And in that context, they have this need of interoperability testing to bring suppliers connected to a lab so that they check whenever the area of use, the line itself, is valid. So and they can somehow support the homologation or certification process around that. So they spent a series of money there for 10 years in order to equip a lab with multi-tail tools in the end, in order to record the dialogue between the devices that will play the role of the final delivery stage. So this was a bid we won 2 years ago approximately, and we had to deliver to them a system level test where we connect, on the one hand, a real onboard, on the other hand, a real trackside. And we, in the middle, had to develop what is so-called a TCL, test control and logging system, that will record the data coming from one and going to the other via a radio bearer system. So that was globally what they were expecting there. Before going to this bid, we had won another bid in Korea. And it's very important to explain that. In the center of the system, we had to put a kind of TCL, but it was not yet a TCL. It was more proprietary-based system. But we had to think about connecting 3 RBCs on the one hand and 2 EVC, or they call it today KVC for Korean Vital Computer, on the other hand. The fact that they call it Korean Vital Computer is because they have this LTER-based communication and no more GSMR-based communication. So that's what they call in Korea. But in this context, the purpose was to mimic, let's say, to have a kind of digital twin of their pilot line, which was 180 kilometers long, with 25 different interlocking systems in the background, and to perform two simultaneous handover over it, with the physical real constituent on the other hand, the real EVCs, connected to the lab. So in the end, we developed that, we delivered that, and this served our, let's say, purpose to have a system which was adequately scaled, I would say, to answer multiple suppliers' connectivity. So the heart of the system was the system-level test bench that we developed for the UK, had a kind of inherits from the experience we had in Korea, where we had to meet performance criteria. 60 simulations, we had to put 60 virtual trains on it to test the line and so on. It was very painful moment for us, but it was very extensive work, but it has served the purpose of UK in the end, because we brought them an optimized revision of the system. We started with Korea. And this approach is very interesting, because in the end, if you think about Brisbane, Sydney, Melbourne, they adopt a test bench, a lab for their trials, interoperability trials, with their specificities and their operational scenario. It's something that is that we can accompany in some way. We could accompany in some way by having a central system that connects all labs all together in order to determine whenever there are interoperability issues, and determine whenever the compatibility is there. So it's something which will avoid painful homologation phase with issues on the field and so on, and anticipate and download it into the lab to make it, let's say, cost effective, in fact, because you spend less. You do not spend the money to rent the line, to rent the train, to bring a series of engineers in the train and so on, to find in the end an issue on the field. The test bench that we use in isolated mode for the device under test, so the onboard, or the test bench that we use for the track side to isolate the track side and test the track side. So that's a subset we developed on our side. And this test bench, they are used themselves as a connector in the system level test bench. So what is very interesting is, imagine that you do a test at system level and you find an issue. It can happen. But then you can discriminate. It's an issue on the onboard side. Okay. But then you can switch down to the isolated mode. So the traditional approach where you just test the constituent in isolated mode with the subset 76, subset 94 traditional approach, I would say. So we have this capability to involve somehow, on the one hand, the test bench testing the device under test in isolated mode, and on the other hand, to let's say to put a switch on this test bench so that it is becoming a connector for the system level test bench. So it serves the purpose of both. And what is also a kind of key advantage we brought there is the fact that because we had to automate the tests for the subset 76 with our robots, we have then all the necessary, let's say, knowledge configuration management that we can recycle when we talk to the system level, so that we can even automate the system level tests itself. And this is a success story we have today in the UK. In fact, they recognize that. At the lessons learned at the end of the project, they said explicitly said it was the least painful project we have ever had.
Hi, this is Doc Frank again. Before you head off, I just wanted to let you know again of the arguably best CBTC conference that has ever been held, the CBTC World Summit 2023, with 18 speakers from 13 different countries. It was a mega event in September this year, and you now have access to the official recording where you can see all the presentations, all the question and answers after the presentations, and even the VIP fireside chats that were exclusively for VIP attendees during the conference. But you can have all of this now lifelong on demand. You can watch it whenever you want, from wherever you want, and how often you want. Don't miss this opportunity and sign up to the best CBTC conference ever on docfranktraining.podia.com/CBTC World Summit 2023. I repeat that, docfranktraining.podia.com/CBTC World Summit 2023. If you want one recommendation from me on CBTC, that is it. The best content of the year by a mile. Don't miss it. Hi, it's Doc Frank again. I hope you liked today's episode. I like to keep it as simple as possible, so I only have one single request for you. If you like this podcast, please tell your friends and colleagues about it. That's all I want, because that's a service that I'm providing to the industry, and I would like as many people as possible to listen to this podcast and learn something from it. So please share, and until next time, keep it simple, and bye for now. Thank you for listening.